Hello everyone. Today we'll be working with a very special chip. It's called as the NVIDIA Nano Jetson. It has 2 GB RAM and it's connected to a 3-volt adapter for power. It has a USB-C port, an HDMI port, 3 USB ports and a LAN port. It is capable of running its own Linux OS. On the heatsink, we'll be placing some homemade fans to minimize the heat dissipation. The fans also connected to the 3-volt adapter. Next, we have a Logitech webcam, as we'll be running a special YOLO V8N model on this chip, and this is the Linux OS run by the chip itself. So this is our ideal setup, which is a webcam being connected to the USB port of the Nano Jetson and the HDMI port displaying on the PC. It's Linux OS. Now let's discuss that how on just 2 GB RAM we were able to run one of the most powerful image detection model, the YOLO V8N, and how it is possible when we have just 2 GB RAM. So this is the exact pipeline which we have been used for the image detection model. First, the webcam captures the video feed, then it is pre-processed by the OpenCV library. It is then passed on to the model inference, the TensorRT, more on it later of the video. Then it goes to the hardware acceleration, which is done by the PyCUDA. That will be also explained further on in the video. Then we can see the output screen. Now this is the demo of the YOLO V8N running on the monitor. As you can see, the bounding box are appearing well enough and detecting objects in variety. The webcam is taking live video feed and then the OpenCV is processing it. Further on, the TensorRT engine is smoothing it and the PyCUDA helping in the hardware acceleration. As you can see, the bounding boxes are made well around the object and it is able to identify the objects in its entirety. It is quite accurate and has a very large sort of range. That is what the benefits we get from the TensorRT engine and the PyCUDA. And this is how accurate the YOLO V8N actually is. Now, TensorRT is NVIDIA's high performance inference engine that takes your model and makes it insanely fast by optimizing precision and execution. Without TensorRT, the video feed would be slow and laggy, but with TensorRT, it will be smooth and will have real-time detection. As you can see, there are the different applications of TensorRT. Now this is the PyCUDA. In the previous flow diagram, you would be able to see PyTorch was mentioned with TensorRT. But here's where the smart move is. Instead of the PyTorch, which is quite heavy for the Jetson Nano, we used the lightweight PyCUDA. What PyCUDA does is, it offloads the heavy computations to the GPU cores of the Jetson Nano instead of relying only on the CPU, as you can see very well in the flow diagram. So, what it does is it uploads to the GPU and runs on the GPU, and it offloads the Jetson from heavy computational calculations. This is how we successfully reduced the load. And with this as the full pipeline, our model was ready to run. Okay, so that was enough of explanation. Now let's get back to what we were actually gonna do. Running the YOLO V8N on the NVIDIA Nano Jetson 2 GB RAM was just the tip of the iceberg. What we actually aim to do is much more than that. Our system is different. So let me show you how it works. First, let me open our system folder in the NVIDIA Nano Jetson's Linux interface. Then open the folder in terminal and write the command to start our front-end file, that is python3 server.py being the file name. After taking much load, in the Chromium browser, it will open the front end of the website. Here you can see the EvilEye front end website appears. More of it in the description box if you want to really explore the website. Now let me explain what the site does. Now as you can see, our EvilEye ecosystem has completely started. As you can see, the webcam is portraying live feed. Now, for instance, if I take the phone in my hand, a red bounding box comes near the phone. It will calculate the amount of time the phone was in my hand in seconds and will give the live feed to the website. It will also take a photo of me holding the phone and will upload to the website as a proof. Here you can see along with the time. And then on the summary dashboard, it will show how much amount of time I was holding the phone and will draw sort of charts and graphs based on it. Another instance, me putting my head down, symbolizing me sleeping. On the top of the camera feed, it will show head down and will start the countdown. It will sort of calculate how much time I was sleeping in class. This being the another instance of me opening my mouth and yawning. It will also calculate the number of times I yawned in the class and the amount of time I was yawning. Based on these three features, phone in hand, my head down, me sleeping and me yawning, it calculates the amount of time I was actually paying attention in the class rather than being physically present, and it will convert it to a grade, a bar chart and much more analysis. So this was our EvilEye ecosystem, which would really help us to note down that how much amount of time we were actually attentive in the classroom rather than just being physically present. It can be implemented on a large scale of students if we use high amount of RAM using high chipsets like the NVIDIA Jetson Orion or the NVIDIA Classic. We can use more powerful chips and implement for more people. As of now, it can detect only 3 students and calculate the grades for them. So this was our EvilEye ecosystem. If you like our system, then please like and comment on the video. We'll upload the whole working in the description box as well for you guys along with the presentation. Hope you like our system and hope it teaches you something new. Thank you. That was all.